In this video, you will learn about units and unit conversions and how we show the conversion process in an organized manner. We will be following these 4 steps. What are you given? Where are you trying to go? What conversion factors can you use to get there? Set up the problem, cancel out your units, and get the correct answer. All right, so let's first talk about equalities and conversion factors. Equalities are used when you have the same amount described with 2 different units. For example, we know that 1 minute, right, is equal to 60 seconds, although minutes and seconds are different units. Okay? Just like 1 pound is 16 ounces, or 2.2 pounds is 1 kilogram. So that's in the English to metric conversion. And we see this, let's just zoom in here, on many food packages. And you can see here that 16 ounces, right, or 1 pound. So you can buy a pound of turkey, right, and that's equivalent to 16 ounces of turkey, just described with a different unit. Okay, one note about equalities: when we write them as conversion factors, you can write, you're going to write one over the other, such as like 1 minute, right, is equal to 60 seconds, right? Or you can flip that around, right? 60 seconds for every 1 minute. Okay. So what's in those parentheses are equivalent units, and that's how you write a conversion factor. Okay, so when we are converting from one unit to another, we use a process called dimensional analysis. Dimensional for using the units, analysis for solving the problem. You're going to set up the problem so that your units will cancel, okay? And you'll end up with the units you want in your answer. Okay, so for example, if we wanted to convert 2 minutes into seconds, so we want the equivalent of 2 minutes, but expressed in seconds. So we can set up a conversion factor. I don't know why I gave so much room over there. Let's just put it closer. All right. So here's our conversion factor. I'm starting with 2 minutes. I want to end in seconds. I'm going to choose the relationship that will get me from minutes to seconds. And I know for every 1 minute, right, that is 60 seconds. And I chose to write the conversion factor in this direction so that the minutes will cancel, right, and my answer will come out in seconds. And then you carry out the math, which is 2 times 60, which is 120 seconds. Okay. So remember, when you have something over itself, right, that is equal to 1. So let's just review that concept. So you know that x over x is equal to 1. 3 over 3 is equal to 1. So a minute over a minute will be equal to 1, and they cancel. So here's just a recap for dimensional analysis. Remember, use the unit. Make sure that the old unit, the one you're trying to get rid of, can cancel. So you'll place it in the denominator. And the new unit that you want, if you want that in the numerator, should be up here in the numerator. Okay. So here's another example. We want to convert 2 dozen into number of donuts. So you will put that 1 dozen is 12 donuts. So that the dozens cancel, your answer will come out in number of donuts. So 2 dozen is equal to 24 donuts. Okay, in your science courses, you will be using the metric system. So why do scientists use the metric system? Well, there's several reasons. One, that it's universal. Only 3 countries use the English system. Everyone else uses the metric system. So you can share scientific information, right, across the world. It's also easy to use, right? It's base 10, right? And also that the prefixes of the metric system, like kilo, centi, milli, they apply to all units of measure, such as, you can have a millimeter for length, you can have a milliliter for volume, you can have a milligram for mass. Okay, so let's go over length. Length, the basic unit in the metric system, will be using the meter. And you can see here this gentleman is holding a meter stick, and it is similar to a yard. Okay? But the meter was determined basically by the measurement of the Earth. So from the equator to the North Pole, going through Paris, 1 meter turned out to be 1/10,000,000th the distance. So there are 10 million meters from the equator going to the North Pole. Okay, so it was based upon the arc of the Earth. Okay, volume in the metric system, it's not written here, is measured in liters. Okay, so the liter is the basic unit for volume, but that is a derived unit. It actually comes from the decimeter, which is 1/10 of a meter cubed. So the cubic air space of the decimeter is equal to a liter, and you should remember that one. So 1 liter is a cubic decimeter. And also that 1 centimeter cubed is 1 milliliter. You'll become more familiar with those prefixes in a minute. Just to help you relate to what a liter is, remember this here is a 2-liter bottle, right? So the large bottles of soda, right? That's 2 liters, so that would contain 2 cubic decimeters. All right, and then mass is measured in grams. The gram here, let me actually give you the little symbol. So it's a little g. Liters, though, is the uppercase L for the symbol. And the gram is also a derived unit. It comes from 1 centimeter cubed, so 1 milliliter of cold water at 4 degrees. So this is H2O, this is a substance. At 4 degrees, when it's the most dense, 1 milliliter of cold water is 1 gram. So that's how the gram was determined, okay, based upon water and a cubic centimeter. Okay, let's learn the prefixes. Some of you may already know this, but some might need a review, and some of these might be new. Okay, so let's look here at the metric system. So remember we said this is, a convenient system because we have these basic units here in the middle. So for length, remember we just said it's the meter. For mass, it's the gram. For volume, it's the liter. Time in seconds. Atom counts in moles, energy in calories or joules, etc. You can have watts, any basic unit you can apply with these prefixes in front. Okay, and it's convenient because you can have, like we just mentioned, you can have a decimeter, a decigram, a deciliter, and it'll always mean 1/10. It means the same thing, which is different than in the English system, where if you're talking about length, you have inches, feet, and yards. If you're talking about mass, you have pounds and ounces. If you're talking about volume, you will have cups, pints, quarts, gallons, etc. And so it gets confusing. Okay? And this way, everything is using the same system. Okay, let's start with the small side. Okay, so deci here, and that means 1/10. 1/10 of a meter, 1/10 of a gram, 1/10 of a liter, etc. So here I'm just writing this in with regards to the meter. So when you write conversion factors, you'll see there are 10 decimeters in 1 meter, or 1 meter in 10 has 10 decimeters. Remember, it's flippable depending on how we're going to use it. So what does 1/10 of a meter look like? Well, it's about the size of a Crayola crayon, about. So here's, 10 would be 10 centimeters, but that's the size of 1 decimeter, 1/10 of a meter. Almost the size, or just a little bit larger than the size of a Crayola crayon. Okay, then we're going to go 100 times smaller, or 1/100th of the meter is a centimeter. So we can write 100 centimeters in a meter, or 1 meter has 100 centimeters. In centi, think of century, that means 100. And a centimeter, here's 1 centimeter right there. That's about the width of a pencil. Okay. Getting even smaller is milli, right? So 10-fold smaller. So 1/1000th of a meter is a millimeter. So 1,000 millimeters in 1 meter, or 1 meter has 1,000 millimeters. And that's about the thickness of a credit card. Okay. Now, instead of jumping by 10, we're going to jump by 1,000-fold. So now it's 1/1,000,000th the size of a meter. And this one is called micro. And the symbol is a mu. So here's, it looks like that. It's a fancy U. And so we can say there are 1,000,000 micrometers in 1 meter, or 1 meter contains 1,000,000 micrometers. This is also called a micron. So those of you that are bio majors and going to take microbiology, a micrometer is also known as a micron. Because this is the size of microbiology, right? These cells are in micrometer sizes, diameters. So let's just write here, bacterium is about 5 micrometers, or microns in size. Human cells are about 25 micrometers in size. All right, jumping another 1,000-fold gets us to nano. Okay. So 1/1000th of the basic unit is the nano. So there are 1 billion nanometers in 1 meter, or 1 meter is 1 billion nanometers. Okay, something in nanometer size, I'll put it right here. Large molecules, so like the thickness of a DNA strand, it's about 2 nanometers. Sizes of atoms are even smaller, right? So they're, that would be a picometer. You'll probably discuss that in Chem 111A. Okay. All right, so that's the small side. And I just want to point out on the small side that if you notice when you write the conversion factor, the meter gets the number 1, right? Because all of these are smaller than 1 meter. The meter's larger and it contains multiples of the other. Okay, so 1 meter contains 100 centimeters. I like to write my conversion factors this way. Okay, instead of saying a centimeter is 1 times 10 to the negative 2. Okay, that made sense. Meters. Okay, now let's go to the large side. So these are all now larger than the basic unit. So we'll see here that like deca means 10, like a decathlon. that 1 decameter has 10 meters in it, right? Or 10 meters is 1 decameter. So notice now that the decameter gets the number 1 and the basic unit has multiples. Okay, so what's the size of a decameter? And this is about the width of a tennis court. So if you put 10 meters in a row, right, that's about the size, the length of the width of a tennis court, the short side. Okay. Hecto is 100, so 1 hectometer has 100 meters, or 100 meters is 1. You could say hectometer. And that, like we said before, the meter is about the size of a yard. So this is about 100 yards. So you can think of the length of a football field. I'll just write football field. Okay, kilo, you might have heard of this one. So a kilometer, especially if you're a runner. Kilo means 1,000, so 1 kilometer has 1,000 meters, or 1,000 meters will make 1 kilometer. And if you're a runner, like a 10K, right, that would be 6.2 miles. So a kilometer is about 1 kilometer is about 0.62 of a mile, right? So 60% of a mile. Let's just write an example here. If you're running like a 10K, that means kilometer, that would be equal to 6.2 miles. Okay. And now again, instead of jumping 10-fold, we're going to jump 1,000-fold to mega, capital M. A megameter means there are 1,000 meters. Okay, 1 megameter, did I say 1,000? 1 million meters. And 1 million meters is 1 megameter. And this is about the distance from LA to Humboldt. That's a city in Northern California. It's almost the size of California, is a megameter. Okay, jumping another 1,000-fold is giga. You might have heard of like gigabytes, megabytes, right? These are the same prefixes. So 1 gigameter is a billion meters, or a billion meters is 1 gigameter. And this is a very long distance. So the only thing I could think of that's close is the diameter of the sun. And that's 1.4 gigameters. Okay, capital G. All right, so those are the prefixes that you guys need to know. Remember, they can be put in front of any of the basic units. So you can have a kilogram, you can have a millisecond, right? You can have, a decimal, you can have a kilojoule, right? So they can apply to any basic unit. You need to know their magnitude. So you have to learn these on this page for your quizzes and exams for this course. Okay, we'll stop right here.